Okay, so the next problem is permutations. A permutation of integers 1 to n is called beautiful if there's no adjacent elements whose difference is 1. So no consecutive elements or yeah, increasing or decreasing. Given n, construct a beautiful permutation if such a permutation exists. The only input line contains integer n, print this. If there's no solution, then print no solution. If there is a solution, it doesn't matter which one you print. Okay, so like an example is in 5, and then we can just input print out 4, 2, 5, 3, 1. So nothing's consecutive. 4 by 2 is minus 2, 2 to 5 is 3, 5 to 3 is 2, 3 to 1 is 2. So nothing breaks the rules. Okay, so whereas if we input 3, then there's no solution because no matter how we arrange 1, 2, 3, it's always going to be consecutive. There's nothing we can do with the 2 that would prevent it from having being consecutive with 1 and 3. Okay, so the idea behind this is that if it's 2 and or 3, then there's kind of no way about this that we can do it. So then we kind of just print out no solution. Otherwise, 1 is actually possible because it's only one thing. So that's why 2 and 3 are not possible. If it's 4, we can do like something like 2, 4, 1, 3, such a thing, right? And then if it's other things, we can kind of work it out in the else statement. Let's just walk through the code directly so I can explain. So we have include IO stream using namespace std using L equals normal. And then we input we define the variables n and d and we input n. Next is the if statement, which checks if it's 2 or 3. 2 and 3 are definitely not possible because we have two or three elements and then they are consecutive and there's no way we can avoid it. Otherwise, we can kind of strategically build our list in such a way that it works out. We have a nice permutation. So in the else statement, we see if n is divisible by 2, then we're just going to set the indicator to be 1. Otherwise, the indicator, let's just say, is 0. So then we just create a for loop. So that for long I equals 1, I smaller than this, we're going to print this. We're just going to print all the even numbers. So then we're just going to print 2, 4, 6, 8, so on and so forth up to that point. And then that is allowed because each one is differed by 2, so there's no overlaps. Then after that, because we're guaranteed that n is either 1, which is already going to be printed, or otherwise 4, then we're just gonna inside here, we're just gonna why did I even print the indicator? I don't even need yeah, because in the for statement, I need to control like basically when it ends. So that's like kind of my indicator to know like the good round so that it has a nice rounding so that it actually works out. And in the second for loop, basically I just print all the odd integers. So then it's just like 1, 3, 5, 7, so on and so forth, so that there's no overlaps with it. Because it's in the case that it's only 1, we're just going to print 1. And in the case that n is greater than or equal to 4, we're going to have 4, and the next one is 1. So then there's a big difference over there of 3. And then each one is going to only get larger, that difference. So there's no overlaps with that as well. So that's just a way of like guaranteeing that there's kind of no overlaps. It's just having that the evens ones and then the odd ones consecutively in increasing sequence. Works out all the time, and it's just a nice way of solving the problem. Okay, let's end it off here.